Imagine you are standing on a surface that looks almost peaceful. The ground beneath your feet glows faintly orange and yellow, like embers dying in the dark. The sky above is black, completely black. No clouds, no wind, just silence and the slow hypnotic curve of Jupiter hanging enormous in the void above you. So massive it fills a third of the sky. For one single second it almost looks beautiful. Then the ground moves, not like an earthquake, slower than that, more deliberate, like something underneath is breathing. And that is when you realize you are standing on the most dangerous place in the entire solar system. Io is Jupiter's third largest moon. From a distance it looks almost harmless. Patches of red, gold, and white stretch across its surface like a painting. Early astronomers looked at it and saw something almost decorative, a small colorful world orbiting the largest planet in our solar system. NASA sent the Voyager probes past it in 1979, and everyone expected to find something quiet, something dead, another frozen rock drifting through the dark. But something was wrong. The images that came back stopped scientists cold. There were no craters on Io, none. Every other moon in the solar system is covered in impact craters, scars from billions of years of collisions. But Io was smooth, freshly resurfaced, like something was constantly erasing it. Then they saw the plumes, rising hundreds of kilometers into space, volcanic eruptions so massive they were visible from the Voyager cameras millions of miles away. Io wasn't dead. Io was alive in the most violent way possible. And what NASA has continued to find in the decades since is something that doesn't just challenge our understanding of this moon. It challenges our understanding of what a world is even allowed to be. Here's the problem. Io exists in a gravitational war zone. Jupiter is not just large. Jupiter is incomprehensible. It is so massive that it doesn't just hold Io in orbit, it squeezes it. Every single orbit, Jupiter's gravity pulls at Io's core, stretching and compressing the entire moon like a ball of clay being worked between two giant hands. This process is called tidal heating, and on Io, it never stops. The interior of Io is not rock. It is a global ocean of magma, not beneath a thin crust, but practically at the surface. The crust itself in many places is just a few kilometers thick, a brittle shell sitting on top of a planet-wide sea of molten rock. The heat generated from Jupiter's grip is so intense that Io pumps out more heat per unit area than anywhere else in the solar system, more than Earth's most active volcanoes, more than the most violent geological events in our history. Scientists estimate Io has over 400 active volcanoes on its surface right now, not dormant, not occasional, active, constantly erupting, several of them simultaneously at any given moment. But it gets worse. In 2023 and 2024, NASA's Juno spacecraft made multiple close passes by Io, closer than any spacecraft had come in over 2 decades. What it found confirmed what scientists had long feared, but hoped wasn't true. The volcanic activity on Io isn't just intense, it appears to be accelerating. Massive lava lakes, some stretching over 200 kilometers across, were observed in states of violent activity. Lava fountains erupting from the edges, heat signatures so extreme they overloaded sensor scales. One of Io's most infamous volcanoes, Loki Patera, is essentially a lava lake the size of a small sea. It overturns, meaning the cooled crust that briefly forms on its surface sinks and fresh magma rises to replace it on a cycle of roughly 400 to 600 days. This is not a metaphor. An entire lake of lava the size of Lake Ontario overturns on a regular schedule like a slow geological heart. And this is where things change, because the question scientists are now asking isn't just what is happening on Io. The question is why it seems to be getting more violent over time. Whether the gravitational tug between Jupiter and Io's orbital neighbors, Europa and Ganymede, is creating a feedback loop that is slowly tearing Io apart from the inside. Whether what we are watching is not just an active moon, but a moon in the process of dying violently over a geological timescale we can barely comprehend. Now imagine you are back on that surface. The ground shifts again in the distance, and on Io, distance means almost nothing because the horizon is close. The moon is small. A column of sulfur dioxide erupts from a vent and rises silently into the vacuum above. There is no sound on Io, no atmosphere thick enough to carry it. You would watch mountains of fire rise in complete silence like a nightmare with the audio cut. The temperature swings on the surface of Io are violent. Near volcanic vents, temperatures can exceed 1,600 degrees Celsius, hotter than most lava on Earth, hot enough to melt iron. But just a few kilometers away from an active vent, the surface drops to negative 130 degrees. You are simultaneously standing next to a furnace and a deep freeze, and the line between them is razor thin. But that's not even the worst part. Jupiter's radiation belts. Io orbits directly inside Jupiter's most intense radiation environment. The magnetic field of Jupiter accelerates particles to devastating speeds and funnels them directly at Io's surface. The radiation levels on Io are so extreme that if a human being were standing on its surface in any suit we have ever built or could reasonably build, they would receive a lethal radiation dose in less than 2 minutes, not hours, minutes. The Galileo spacecraft that orbited Jupiter from 1995 to 2003 had its electronics degraded by radiation damage even at distances far greater than Io's orbit. When it made its closest passes to Io, engineers held their breath. The spacecraft wasn't designed to survive that environment for long. It wasn't supposed to be there, neither were we. What NASA's ongoing study of Io through Juno is teaching us is something deeply unsettling. We look for life in the universe. We look for warmth, for water, for the right conditions. And Io has warmth, enormous violent warmth. It has chemistry. It has energy. Some scientists in quiet moments have asked the question nobody wants to take seriously. Could something survive in Io's subsurface environment, deep beneath the radiation, in the magma ocean below? We don't know. We don't know because we have never been close enough for long enough. We have never landed. We have never drilled. We have sent our best machines to look from a distance, and even they barely survived the attempt. There is something on Io that resists being understood, not because it is hiding, but because the universe around it makes the act looking almost impossible for anything we can build, anything we can send, anything we are. Io has been doing this for billions of years. Long before there were eyes to see it, long before there was anyone to be terrified by it, Io was erupting, turning itself inside out, erasing and rewriting its own surface in fire and silence in the dark between Jupiter's moon. It will still be doing this long after we are gone. The universe does not build places like Io for us. It does not arrange its most violent and extreme environments with human curiosity in mind. We arrived late to a solar system that had already decided what it was going to be, and places like Io are a reminder, quiet and enormous and completely indifferent, that for all of our telescopes and probes and equations, most of what exists out there is not waiting to be explored. It is simply waiting, and it does not care whether we come or not.